We are discussing the chemical technology course organic part, and in this we are discussing the module 1. In module 1 lecture 1 we discuss about the status of the chemical process industry. In module 2 in lecture 2 we discuss about the raw material for the chemical process industry, and lecture 3 will be discussing about the various basic principles of unit processes and unit operation in organic chemical industry. A basic principle of the chemical process industry. Chemical process usually have 3 interrelated elementary process: transfer of the reactant to the reaction zone, chemical reaction involving various unit processes, and then the separation of the products from the reaction zone using various unit operation. Process may involve homogeneous system or the heterogeneous system. In homogeneous system, reactants are in same phase, liquid, gases or the solid, while heterogeneous system include 2 or more phases: gas liquid, gas solid, gas gas, liquid liquid, liquid solid, etc. Various type of the reaction involve many reversible or irreversible, endothermic or exothermic, catalytic or non-catalytic. So, you can see the chemical process industry a very complex nature. Various variables affecting the chemical reactions are temperature, pressure, composition, catalyst activity, catalyst selectivity, catalyst stability, catalyst type, the rate of heat and mass transfer. Information important for the development of a process and its commercialization, that is the basic chemical data, yield, conversion kinetics, material energy balance, raw material energy consumption per ton of the product, energy changes. Information important for the development of the process and its commercialization: batch or the continuous process, chemical process selection, design and the operation, pilot plant data, equipment required, material of construction. Chemical process control and instrumentation, chemical process economics, competing processes, material and energy cost, labor, overall cost of the production. This is very important aspect in case of the chemical industry, because the cost of the raw material, that is varying from 40 to 50%, in some of the cases it may be 20 to 30, but in many cases it is around 40% of the total cost. And so, the cost of the raw material, energy, labor, overall cost, that is very important aspect. Market evaluation, purity of the product and uniformity of the product for further processing. Plant location, because this is the one of the very important factor. While locating any chemical industry or any industry, you will have to take into consideration many factors, whether the location of that plant will be economical or not, availability of raw material and other aspects we will have to see. Chemical process control and instrumentation. You see there has been vast changes in the chemical process industry, and the control and instrumentation part that has played very important role in the development of the chemical process industry. And now the chemical process industry is very complicated, and lot of the instrumentation is there. Another aspect in case of the chemical process industry is chemical process economics, competing process, material energy cost, labor, overall cost of the production, market evaluation, purity of the product, and uniformity of the product for further processing, plant location. Now, some of the another changes that has taken place in the chemical process, and now they are playing very important role in deciding the location and at the same time the processes, the environment, health and safety and hazard part. Because now the concept that has changed from the environment to health or safety, now it is the C, that is the safety, health and the environment. Construction, erection, because after deciding the everything about the location, everything, the next part that is the construction, erection, the commissioning of the plant. Management for productivity and creativity. That is one of the very important aspect in case of the any industry, training of the plant personnel and motivation at all levels, because unless until the people are motivated, we cannot achieve our target, we cannot achieve our improve our productivity. So, the participation of all the personnel, whether at the junior level or the senior level, that is very important for improving the productivity. Research development patents. So, this is also because continuous effort that is being taken for the development of the process, for improvement of the yield or the conversion in the chemical process. So, in-house research and development, that is also very important for any development inside the plant. Chemical process industry, if you see, that is the chemical production, that is the function of the chemical changes and the physical. These are the two things that is happening in case of any chemical changes, the chemical by the reaction of the some of the reactants, we are producing some product, and then the products which is made, how to separate it. For that we are having the unit operation, that is the physical changes that is taking place. So, chemical change that is dealing with unit process, and physical changes that is dealing with the unit operation. Fundamental knowledge of the unit processes and the unit operation in a coordinated pattern for successful commercialization of chemical processes and the products is very essential, and this is the changes that has taken place, and whatever the changes now we are seeing in case of the chemical process industry. If you compare the chemical process industry of the 1950 and the now, there has been sea changes in the capacity, energy conservation measures and the environmental pollution control measures. Even the capacity wise, earlier we used to have a very low capacity plant, now we are having the very high capacity plant. Then earlier the separation of the products which we are getting from the various unit process, that was a very difficult task, especially in case of the when the close boiling points were there or the azeotropic mixture was there. So, in that case the purity of the product at that time, it was very difficult to get the very pure component from a reaction. So, now what is happening because of the development which has taken place in case of the unit operations, now the separation that has become much more easier, and one of the example, that is the adsorption and liquefaction that is being used in case of the petroleum industry. So, the chemical process is combination of the unit processes and unit operations. Unit process involves principal chemical conversion leading to the synthesis of the various useful product and provide basic information regarding reaction, temperature and pressure, because this is the initial stage, how the development in the chemical engineering that took place. That was the initially, it was the chemistry to industrial chemistry to the chemical technology, and then it was the chemical technology to the chemical engineering, because some of the information about the various process that was available earlier also, but how to go for the separation of the products which you are getting, how to improve the yield, that is the catalyst development, or what are the things that you can use for the controlling the temperature, then the instrumentation part, all those development that has been there only because of the coming of the chemical engineering curriculum. The extent of the chemical conversion and the yield of the product of the reaction, nature of the reaction, whether it is endothermic or exothermic type of the catalyst. There has been always continuous development in the catalyst for the chemical process industry, just to improve the productivity, just to increase the yield, just to increase its resistance towards the various poisonous catalyst poisons which are there in, especially in case of the petroleum industry. So, this is some of the development which are taking place, and the combination of both the knowledge of the unit process and unit operation, that is very important. Unit processes, now we will discuss about the unit process in the chemical process industry. What are the various unit process that we are using? Alkylation, hydroalkylation, acylation, ammono-oxidation, amination by reduction, amination, aromatization, amination by aminolysis, calcination, decomposition, fermentation, halogenation, hydrogenation, hydroformylation, hydrolysis, hydration. carbonation, castization, chlorination and oxychlorination, because this is the process chlorination, oxychlorination. Now what we are having in case of the earlier in the manufacture of the vinyl chloride, we are using the chlorination. Now we are using the oxychlorination. Condensation, biomethanation, carbonization, that is very important in case of the coal carbonization, biomass carbonization, disproportionation, that is important in case of the when we are converting the tile into the more value added product xylene and the benzene. Hydrolysis, isomerization, again isomerization, that is playing very important role in case of the chemical process industry, in case of the refinery, that we are using for improving the octane number of the low octane naphtha. Similarly, in case of the isomerization of the metaxylene to paraxylene, that we are doing in case of the paraxylene manufacture, neutralization, nitration, methanation, oxidation and the partial oxidation. Other unit processes now that has become very common, that is the cracking and pyrolysis, dehydrogenation, detergation, coupling and the gasification and of coal and biomass, desulfurization, hydrodesulfurization, because there has been a lot of the change in the case of the desulfurization, hydrodesulfurization and the requirement, especially in case of the petroleum refinery industry to meet the norms of the various fuels, it may be gasoline or the diesel, or to meet the requirement of the feed for the various process. Electrolysis, that is very important in case of the caustic chlorine manufacture. Etherification we are using at the various stages in chemical process industry. Thermal and steam cracking, catalytic cracking, because this is the how the evolution that has taken place in case of the cracking process. Earlier it was the only thermal cracking, then thermal cracking to catalytic cracking, just to improve the economy of the process and reduce the temperature and to have the better quality of the product. Steam cracking, that was developed for the actually the cracking of the naphtha, cracking of the gases, where we are producing the olefins. Reduction, reforming, steam reforming, catalytic reforming, steam reforming, that is very important for the manufacture of the hydrogen, for the manufacture of the synthesis gas. Catalytic reforming we are using in the refinery and the petrochemical complexes for the manufacture of the, for improving the octane number of the naphtha and at the same time for the production of the paraxylene. Sulfidation, sulfonation, because sulfonation in many of the processes we are using, sulfation, accentuation, that is the process we are using in case of the viscose rayon. These are the some of the important chemical reaction that we are coming across in the chemical process industry, that is the Fischer-Tropsch process. The Fischer-Tropsch process produces a variety of hydrocarbons, alkanes by a series of chemical reaction that is happening, and the reaction and that is the FT process used for the synthesis of alkanes, FT synthesis for the production of fuel from coal, because that has become very important after, because now the many places now we are using the coal for the production of the synthesis gas, and from synthesis gas to fuel and value added other value added product and chemicals. Friedel-Crafts reaction, that is also very important. In this reaction, attach substituents to an aromatic ring. Two main types of the Friedel-Crafts reaction are acylation reaction and the alkylation reaction, both proceeding by electrophilic aromatic substitution. This is the reaction that is taking place in case of the Friedel-Crafts reaction. Oxosynthesis, in this process isomeric mixture of the normal and isoaldehydes get produced by utilizing synthesis gas and olefinic hydrocarbons. It is exothermic process. This process thermodynamically favorable at ambient pressure and temperature. This reaction also called a hydroformylation reaction. Hofmann reaction, in this process organic reaction of the primary amide converts into primary amine with one fewer carbon atom. So, this is also very important in case of the chemical process industry, and the reaction that is taking place, this is the reaction which is taking place in case of the Hofmann reaction. Beckmann rearrangement, that is one of the very important reaction that is taking place, especially in case of the manufacture of the caprolactam that we are manufacturing. caprolactam. In the process of making of the caprolactam from cyclohexane, that the process in the last pass is the Beckmann arrangement, where the acid catalyzed rearrangement of a oxime to an amide in cyclic oxime is converted into lactams, that is the caprolactam that you are getting. So, this is the reaction which is taking place in case of the caprolactam manufacture. Free radical reaction, again they are very important in many of the polymerization reaction or in many of the other reaction, that is the free radical reaction that is taking place. Any chemical reaction involving free radicals, generate radical generated from the radical initiators. Radical reactions are chain reactions with chain initiation, propagation and termination. These are the three steps normally that is taking place in case of the free radical reaction. Free radical reactions are used in many organic synthesis and the polymerization reactions. Wacker oxidation is similar to hydroformation and used for aldehyde compounds, and this is the palladium catalyst that we are using this reaction. This is the reaction that is taking place. Nitration, that is one of the very important reaction in case of the chemical process industry. Nitration involves the introduction of one or more nitro groups into reacting molecules using various nitrating agents like fuming, concentrated aqueous nitric acid or mixture of nitric, because the mixture of nitric is mixed acid that we are using in case of the manufacture of the TNT, trinitrotoluene, that is there, and in many of the other chemical process industry we are also using the mixed acid instead of the nitric acid. So, that is also coming in this part, that is also part of the nitration. Nitration products find wide application in chemical industry as solvent, dyestuff industry, the pharmaceuticals, explosive, chemical intermediates. Typical products are TNT, nitrobenzene, because nitrobenzene that is very important product in the chemical industry, meta-dinitrobenzene, nitroacetanilide, alpha nitronaphthalene and nitroparaffins. Example of preparation of the TNT. TNT is produced in a 3 steps, that is in the first step MNT is made, and there we are using the mixed acid as a catalyst. MNT is then we are getting DNT, and from the further nitration we are getting the TNT. This is the reaction that is taking place in making of the nitrotoluene from the toluene. Halogenation. Halogenation, that is also very important reaction in case of the chemical industry, because many of the halogenated products we are using in some or other form. So, halogen involves introduction of one or more halogen groups into a organic compound for making various chlorine, bromine, iodine, fluorine, organic derivative. One of the very important reaction that is in case of the halogen, that the manufacture of vinyl chloride through ethylene dichloride. Ethylene dichloride again that is produced by the chlorination of the ethylene. Although the chlorine derivatives find larger application, however, some of the bromine and fluorine derivatives are also important in case of some of the brominated compound also we are using in the process. Various chlorinating agents are chlorine, HCl, phosgene sulfuric chloride or hypochlorite that we are using. In bromination, bromine, hydrobromine, bromic acid, bromide, bromated, alkaline, hypobromides. These are some of the brominating agent that we are using. In iodinization, iodine, hydroiodic acid and the alkali hydroiodides that we are using. Typical example are chlorinated products, ethylene dichloride, chlorinated methane, chloroform, because in case of the chlorination of methane, number of products we are getting during the chlorination, that is the chloroform, carbon tetrachloride, then the chloroethane, chloropropane, chlorobutanes, chloroparaffins, chlorination of the acetaldehyde, alkyl halides, chlorobenzene because that is the starting material for the nitrobenzene. So, chlorobenzene, this was the earlier process, other process also there was chlorobenzene to nitrobenzene, ethylene diiodide, chlorofluorocarbon, that is the use of the fluorine. This is the reaction that is taking place in case of the chlorination of the methane. Sulfonation and the sulfation, that is also one of the very important reaction in case of the chemical process industry, where we need some of the sulfonated compound. Sulfonates involve the introduction to of sulfuric acid group or the corresponding salt like the sulfonyl halide into an organic compound, while sulfonation involves introduction of the OS, SO2 OH group or the SO4 group. Various sulfonatic agents are sulfur trioxide and compounds sulfur trioxide, sulfo-alkylating agent. Some of the sulfamic agents are sulfamic acid. Apart from the sulfonation and sulfamation, sulfochlorination, sulfo-oxidation is also being used. Typical example of the sulfonation and the sulfation are the production of the lignosulfates, where this is very important because the lignin which are getting from the paper industry, that we can the lignin that we separating during the pulping process, and that lignin that can be used for the manufacture of lignosulfate, toluene sulfonate, phenolic sulfonates, chlorosulfophonic acid, sulfates, production of herbicides, sweetening agent, oil soluble sulfonate and the saccharin. This is the typical example of the sulfonate that we are using in case of the preparation of the sulfamic acid, the saccharin, sorry. Oxidation, again oxidation, that is important reaction in case of the any chemical process industry in the various stages. Just one typical example is ethylene, from ethylene to ethylene oxide, where oxidation of ethylene, that is. So, oxidation is used extensively in the organic chemical industry for the manufacture of large number of the chemicals. Oxidation using oxygen or combination of the various reactions like oxidation via dehydrogenation, using oxygen, dehydrogenation and the introduction of oxygen and destruction of the carbon, partial oxidation, peroxidation, oxidation in presence of a strong oxidizing agent, chlorate, dichromate, peroxide, hydrogen peroxide, all these things, that is the some of the additional actually the agent that may be there during the oxidation along with the oxygen. Oxidation, partial oxidation, that is one of the very important process in case of the oxidation of the coal, oxidation of the heavier residues you are getting from the petroleum products for the manufacture of the synthesis gas, and that extensively that is being used in the chemical process industry, petroleum refinery, fertilizer industry. Some of the important product of the oxidation are aldehydes, ketone, benzyl alcohol, phthalic anhydride, ethylene oxide, vanillin, benzaldehyde, acetic acid, cumene, synthesis gas from hydrocarbons, propylene oxide, benzoic acid, malic oxide, benzaldehyde, phthalic anhydride and so on. Oxidation may be carried out either in liquid phase or the vapor phase. This is a typical example of the synthesis gas from the hydrocarbon, and that is taking place by the Fischer-Tropsch reaction. Hydrogenation, that is also one of the very important reaction and involves the reaction of a substance with hydrogen in the presence of a catalyst. Some of the other reaction involving hydrogen are hydrodesulfization, the process which we are using in case of the petroleum refinery, hydrocracking, again in case of the petroleum refinery now we are using hydrocracking along with the fluidized bed catalytic cracking for the cracking of the heavier residue which we are getting from the atmospheric column or the light gas oil from the vacuum distillation. Hydroformylation, oxosynthesis, hydrolysis and the synthesis of the ammonia. Esterification is an important process in the manufacture of polyethylene terephthalate, methyl methacrylate, cellulose ester in viscose yarn manufacture, nitroglycerin. Hydrolysis is used both in inorganic and organic chemical industry. Typical application is in oil and fat industry during soap manufacture. Hydrolysis of fats are carried out to obtain the fatty acid and glycerol followed by addition of sodium hydroxide to form. This is the process we are using in the case of the soap manufacture. Other application is in the manufacture of amyl alcohol. Some of the major products which we are getting from the hydrolysis using hydrogen is ethylene from acetylene, methanol, propanol, butanol, production of alcohol from olefins, etc. Various type of the hydrolysis reaction may be pure hydrolysis, hydrolysis with aqueous acid or alkali, dilute or concentrated, alkali fusion, hydrolysis with enzyme and catalyst. This is the typical reaction in case of the preparation of the ethanol from the ethylene, because for the ethylene there are two routes. One is the from the ethanol route, another is from the ethylene route. So, from the ethylene route that we are getting by this reaction the ethylene. Alkylation involves the introduction of an alkyl radical into an organic compound by substitution or the reduction. Products from alkylation find while application in detergent, lubricants, high octane gasoline, photographic chemicals, plasticizer, synthetic rubber chemicals. Some of the alkylating agents are olefins, alcohols, alkyl halides. Here actually in case of the alkylation process, that is now we are using in case of the petroleum refining and the petrochemical industry both, alkylation for producing the high octane gasoline, and in case of the petrochemical we are for the manufacture of the linear alkyl benzene, where the alkylation process finally alkylation of the benzene with the one alkyl group, that we are getting the linear alkyl benzene. There has been a lot of the change in the alkylation process regarding the catalyst, because the sulfuric acid and the phosphoric acid were commonly used as catalyst in alkylation process earlier. But in case of the sulfuric, if you compare sulfuric acid and phosphoric acid consumes less acid in comparison to sulfuric acid, and that was the reason why the alkylation process that was shifted from sulfuric acid to phosphoric acid. But still in case of the this phosphoric acid and sulfuric acid both, lot of the corrosion problem was there. And now the new development in case of the alkylation process, that has been to go for the solid acid catalyst. That was because of the your corrosion problem. Preparation of the toluene, alkylation that may be from the benzene to toluene, although this is not very common process, but you can get the toluene from the benzene. Polymerization reaction, because you see the polymerization, at the same time oligomerization or trimerization, these are some of the polymerization reaction that is taking place, and they are very important in case of the manufacture of especially the polymer, synthetic fiber, synthetic rubber. Polymerization may be carried out in either with single monomer or with the co-monomer, because in case of the polythene we are using some co-monomer also, vinyl fibers also, sometimes the vinyl chloride that is being added as a co-monomer in manufacturing some of the fiber. So, it may be monomer or the co-monomer, both that is being. Polymerization reaction can be addition or the condensation reaction. Various polymerization methods may be bulk emulsion, solution or suspension polymerization. Any of these process that is being used depending upon the requirement of the process. These are some of the major products which you are getting through the polymerization: PVC, polystyrene, nylon, both the nylon 6 and nylon 66, polyester from the terephthalic acid, acrylic fiber that we are getting from the polymerization of the acrylonitrile, polybutadiene that we are because you see the butadiene that is available from the steam cracker. So, instead of going for the manufacture, as we are many of the plants which are having the naphtha cracker, they are making the polybutadiene, polystyrene, urea, various actually the phenolic reagents that you can say, the urea, melamine, phenolic, phenol formaldehyde. These are some of the other reagents that we are making. Thermoset reagent, that is not the phenolic but the phenolic, urea and the melamine formaldehyde. This is the typical actually the reaction that is taking place in case of the polyethylene. Polyethylene, in case of the polyethylene we are sometimes we are using the butene 1 as also as a co-monomer. Now we come to, because we discussed about the unit process. Now the unit process, by the various unit process, various reaction, you are able to produce some product. But how to separate it, that was a major challenge during the initial stage of coming of the chemical process industry, because all these processes now you are seeing in case of the unit operations were not well developed. So the problem was then the separation to get the good quality, better quality of the product and the better separation. So, and at the same time to improve the productivity through the lesser energy consumption. These were some of the issues earlier, and how the evolution of the chemical engineering that took place. That was the reason how from the chemistry to industrial chemistry to chemical technology, and then finally it was in the hand of the controlling the chemical industry that came to the chemical engineers. So, unit operations involve the physical separation of the products obtained during the various unit processes. A large number of the unit operations are there which are being used in the chemical process industry, in petroleum refinery, petrochemical industry. First, one of the very common actually the unit operation which was there, that is absorption and steeping, adsorption, desorption, pressure swing adsorption. That was the development in case of the adsorption, and now whatever the separation of the air that is possible, because earlier we used to have the liquefaction of the air for getting the oxygen, nitrogen. Now with the coming of the pressure swing adsorption, we are able to produce oxygen, nitrogen even at a lower capacity. Distillation, that may be the batch or the continuous, flash distillation, azeotropic, extractive, and the newer development is the reactive distillation, where the simultaneous reaction and the distillation both are taking place. Membrane process, although the membrane or the filtration, that was the from very beginning that was being used, but the real development that came when the problem of the your purification of the sea water, how to get the drinking water or the processed water from the sea water. So, the major development was because of that, but now the membrane process, which are the various type of the membrane process that has been developed, reverse osmosis, ultrafiltration, dialysis, electrodialysis, per evaporation, all those processes that have been developed and that is being used. One of the another example of the membrane process, that was the coming of the caustic chlorine plant based on the membrane process, because earlier we are using the diaphragm cell process. Diaphragm, it was shifted to the mercury cell process because some advantage of the mercury cell process was there, but again the mercury pollution problem, because the mercury pollution, now all the caustic chlorine plant, they are based on the membrane process. Then another important unit operation, that is especially in case of the mineral industry, cement industry, refractory, that is the crushing, grinding, pulverizing and screening, because these are some of the very initial stages, especially in case of this. You take the case of the cement industry, lot of the changes that has taken place in case of the unit operation for the crushing or the pulverizing. Earlier the boiler, we are using the non-pulverized coal. Now we are using, because high capacity boilers are there, now we are using the pulverized coal. In case of the cement manufacture, we are having the crushing and grinding. Earlier we used to have the ball mill grinding, now we are having the vertical roll mill or the press roll. Then the solid liquid extraction. Some of the other separation process unit you can, that is part of the unit operation, that is the evaporation, fluidization, that was from the fixed bed to fluidized bed, moving bed, that came into existence. Crystallization, liquid extraction, even the crystallization and liquid extraction that is being used extensively in case of the petroleum and petrochemical industry. In case of the petroleum, when you are separating the your close boiling point component, that is the paraffin from the aromatic, we are using the liquid extraction. For the separation of the paraxylene, we are using the crystallization process, steeping, sublimation, that is another process that we are using in case of the polyester manufacture. Not the polyester exactly, that is your purification of the terephthalic acid, solvent extraction. Now we will discuss some of the important actually the unit operation that is being used. Distillation, that is called the king of all the separation process and most widely used in separation technology and will continue as an important process in the future also, because you see the if you cannot imagine any process, chemical process, whether it may be petroleum or the petrochemical, without the distillation column, because we are using for this for the separation of the reactant, we are using the distillation. That is, the distillation process involves the separation of binary mixture or the multi-component system or the multi-component mixture, as in case of the crude oil. Separation is based on the difference in the boiling point and the relative volatility. Sometimes there is problem in case of when the closed boiling point is there, but still there are some development in the distillation process, that is the azeotropic and extractive distillation, and so we can also process the closed boiling components. So, this is about the azeotropic, when the casting boiling mixture composition of the liquid mixture is same as vapor, and so the separation is difficult by the conventional distillation. Azeotropes may be homogeneous or the heterogeneous. Distillation of the constant boiling mixture can be achieved by adding a third component, that we are using in case of the azeotropic distillation or the extractive distillation, to form a tertiary mixture with no azeotrope, and so the separation that becomes easier. So, why we call it the azeotropic or the extractive distillation? Azeotropic, in the case of the azeotropic distillation, third component high in the distillate. In case of the extractive, the third component high in the bottom product. So, this is the basic difference in case of the one of the example that you can say, the even in case of the nitric acid, where the after the 55% I think that is about the nitric acid, you will have to concentrate by the azeotropic. That is the distillation that is involved for removal of the water. Same thing is happening in case of the alcohol. Even in case of the many of the mixture, in case of the refinery, we need the azeotropic distillation or the extractive distillation. So, these are the some of the development that has taken place in case of the distillation, that is the superfractionation, reactive distillation, plate column, bubble, sieve, plate, valve plate. So, these are the some of the in case of the plate column, then the packed column, again in case of the packed column, lot of the development that has taken place. Structure and non-structure packing. Packings, the earlier normally we are using the racings in the bird saddles, now it is the interlock saddles, spal rings, nutter rings, etc. Distillation is used in, as I told you earlier also, this is being used extensively used in the petroleum refinery and petrochemical. We cannot imagine a refinery or the petrochemical complex without a distillation column. It is the heart of the petroleum refining, and all the process required distillation at various stages of whether from the very beginning crude oil distillation to the catalytic reforming, or it may be the FCC for separation of the various products which are formed during the process, we need the distillation. Same thing happening in case of the many of the petrochemical process also. Membrane process have emerged one of the major separation process during the recent years, and finding increasing application in the desalination, because this was the actually how the evolution of the membrane process that came. The application in the desalination, wastewater treatment, now we are using the membrane process in wastewater treatment also, gas separation and the product preparation. Now in case of this separation of the CO2 from the hydrogen, from the natural gas or from the synthesis gas, membrane process, now the membrane is available, you can go for the separation of the CO2 from the hydrogen other than the conventional process. So, that is the how the development that has taken place in case of the membrane process and the product. Only the problem in case of the constraint in case of the membranes process is the your choking of the membrane, cast of the membrane, but there is continuous development in case of the membrane also to improve the cost. Improve the cost means the lower cost of production that may be for the membrane. So, the now extensively we are using the membrane process. Earlier I told you that in caustic chlorine manufacture, one was the major application of the membrane process in the caustic chlorine. even in case of the petrochemical process that we are using the membrane process. Membrane technology is vital to the process intensification strategy and has continued to advance rapidly with the development of the membrane reactor. Now we are talking about the membrane reactor also, catalytic membrane reactor, membrane distillation also. Now we are talking about these are some of the new development, membrane bioreactors for wide and varied application. Now we will be discussing about the various membrane processes. As I told you, there has been continuous development in the case of the membrane process, and so now we are having a large number of the membrane processes where the driving forces that is different. That is the first actually the reverse osmosis and ultra filtration that has been used from very beginning, and so here the driving force is the pressure difference, microfiltration, nanofiltration. In all these processes the pressure difference is the driving force. Dialysis is the concentration difference, polymerization concentration difference, liquid membrane concentration difference. Electrodialysis, the electrical potential is the driving force, and gas permeation concentration difference. Thermo-osmosis, the temperature difference, that is the driving force. So these are the various type of the membrane separation process which we are using in some or other form in the chemical industry. The various type of the membrane process, again the what are the separation mechanism and the feed is steam, microfiltration, sieving, ultrafiltration, sieving, liquid or gas or liquid, dialysis liquid, reverse osmosis liquid, evaporation liquid, gas and vapor permeation, liquid vapor. So these are the various type of the membrane process that is being used. Gas membrane application area, as I told you earlier also we are using the membrane, not it is not only limited to desalination process or the caustic chlorine manufacture. Now the it is finding application in the chemical industry for the other purpose also, just like we can see the one of the oxygen nitrogen, generation of the oxygen, enrichment inert gas, hydrogen hydrocarbons refining and hydrogen recovery, H2 and CO synthesis gas adjustment, hydrogen nitrogen ammonia purge gas, CO2 hydrocarbons acid gas removal from the natural gas. These are the some of the process that we are using in the even in refinery. Some of the process that being H2 hydrocarbon natural gas dehydration for the because the your presence of the moisture that create lot of problem in case of the natural gas, and that has to be removed. So this process that can be used. H2S hydrocarbon for sour gas treating, means the treating of the sour gases, that we can use the membrane process. Helium hydrocarbons, helium separation, helium nitrogen, helium recovery, hydrocarbon air, hydrocarbon recovery, hydrogen air for the air dehumidification. Another process, as I told you, the absorption from very beginning, that has been some or other form that is being used in the chemical process industry, is one of the most commonly used separation techniques for the gas cleaning purpose, for the removal of the various gases like H2S, CO2, SO2, ammonia, even for the chlorine, that we are using some of the absorbent for absorbing these gases for removal of even the process industry. Suppose in the manufacture of the ammonium hydroxide, in the manufacture of the sulfuric acid, or in the manufacture of oleum, we are using the absorption process. So it is not from the, but from the environmental point of view, the absorption process, that is very important, but at the same time it is also very important in many of the chemical process industry. Solvent, because two parts are there in case of the one is the solvent and another is solute, which is to be removed from the gas stream. So liquid applied to remove the solute from a gas stream, components to be removed from the entering the stream, solvent, various solvent that has been, because there has been continuous development in case of the solvent also. Now the amines, they are very mono, MEA, DA, diethanolamine, or the triethanolamine, diethylene glycolamine, or methyl diethanolamine. So some of the actually the amine solvents now that is being extensively used in even in case of the refining also. The carbonate process K2CO3, that was the one of the oldest actually absorbing media that was being used for absorbing the CO2 during the ammonia manufacture. Now it has in many of the places that has been replaced with the MEA or it may with the methanol and various combination of the potassium carbonate just to reduce, because that process of the CO2 absorption highly corrosive atmosphere is there. So, we are using some of the corrosion inhibitor, and so the some of the corrosion inhibitors they have been added here. Arsenic dioxide, that is one of the corrosion inhibitor. Physical absorption, polyethylene glycol, dimethyl ether, NMP, methanol, sulfonane mixed with an alkylamine and the water. So, the sulfur. Another development in the case of the separation process that has been the adsorption, that is the physical adsorption technology is now used very effectively. That was earlier for the carbon adsorption, that is one of the very common process use of the activated carbon in case of the purification of the water. From very in the ancient time, charcoal that was being used for the cleaning of the theatre, even in case of the purification of the water. That has become a very important separation process in case of the petrochemical industry for the separation of the many gases and liquid mixture in the petrochemical industry, biochemical industry, and as I told you for the environmental pollution control in the case of the treatment plant, and is often a much cheaper and easier option than distillation, absorption or the extraction. Some of the commercial adsorbent are the silica gel, activated carbon, carbon molecular sieve, charcoal, zeolites, molecular sieves, polymer and resins, clays, bioabsorbents. So, these are the some of the commercially available because of the coming of the molecular sieve. There has been lot of the application of the adsorption process, even adsorption and the pressure swing adsorption. That is being used in case of the separation of the many chemicals in case of the petroleum, the petrochemical industry. One of the, because you see some of the methods used for the regeneration before going to the application of the various adsorption process in the chemical and the petrochemical industry. Let me discuss about the regeneration, because the regeneration that is very important in case of the adsorption. Like the in case of the catalyst, if you are using, you will have to regenerate. Here also the regeneration that is very important, and for the regeneration of the adsorbent we are using the thermal swing, pressure swing, vacuum. So, pressure swing adsorption where we are increasing the pressure, reducing the pressure, and so desorption is taking place. So, pressure swing adsorption, this is the why it is called the pressure swing adsorption, that is being used for the separation of the oxygen and nitrogen, and even in case of the paraxylene purge and the gas stripping steam. These are the some of the commercial processes which are being used in case of the petrochemical industry. Parex for the separation of the paraxylene from mixed C8 aromatic isomers, then the MX Zorbex, metaxylene from mixed C8 aromatics, Molex process that we are using in case of the manufacture of the linear alkylamine, linear paraffin from branch and cyclic hydrocarbons, Olex process that is from the because some of the olefins they are having the close boiling point, especially when we are separating the C4 components from the FCC gases or the steam cracker. So, for the separation of the close boiling olefins, the Olex process that is being used. Chrysex, paracresol, Cymex for separation of the paracymene, Cyrex for the fructose. These are the other some of the other application of the adsorption process. This is the one of the adsorbent that has been developed by UP for the separation of the normal paraffins from the hydrocarbon mixture. Kerosene isotope process for the separation of state chain normal paraffin from the kerosene range used for the detergent industry. Pressure swing adsorption, as I told you, that is being used in the chemical industry, is based on the principle of relative adsorption strength, is a milestone in the science of the gas and separation. Some of the commercial applications of the PSA are air dyeing, hydrogen purification, bulk separation of the paraffins, air separation for oxygen nitrogen production. Crystallization process. Crystallization process, earlier it was only limited to the sugar industry, when the crystallization of the sugar and we are separating the molasses from the sugar, but now it has come in a big way in separation of the some of the close boiling point, especially in case of the separation of the paraxylene from the xylene steam. The process involves the nucleation, growth and the agglomeration and the xylene. Typical process of the separation of the paraxylene involves cooling the mixed xylene feedstock to a slightly higher than that of the eutectic, followed by the separation of the crystal by centrifugation or the filtration. So, this is the process extensively that is being used, because there we are having the two process for the separation of the paraxylene. One is based on the adsorption and this is based on the crystallization. Liquid extraction, because you see the liquid extraction again it is being very commonly used in the petroleum and petrochemical industry for separation of the close boiling hydrocarbons. Some of the major application of the liquid extraction are removal of the sulfur compound from the liquid hydrocarbons, recovery of the aromatics from liquid hydrocarbons, separation of the butadiene from C4 hydro, because here also the same problem with the close boiling point. Components are there, and so we are separating by liquid extraction of the caprolactam, separation of the homogeneous aqueous azeotropes, where this liquid extraction, and there has been continuous development in case of the solvent that is being used. Now the NMP, sulfonate and dimethyl formaldehyde, these are some of the solvent which has been developed and finding wide application, because earlier we used to have the phenol, we used to have the furfural, these were some of the solvent that was being used. Other application of the liquid extraction are extraction of the acetic acid, removal of the phenolic compounds from wastewater, manufacture of rare earths, separation of the aspartic compounds from oil, recovery of the copper from leach liquor, extraction of the glycerides from vegetable oil. Some of the important property for the good solvent, because the choice of the solvent, that is also very important. High solvent power capacity, high selectivity for desired component, sufficient difference in the boiling points of the solvent and the feed, because you will have to strip the solvent from the product, and so the separation only it will be possible when there is sufficient difference in the boiling point. High solvent power capacity, high selectivity of the desired component, because the component which has to be removed, sufficient difference in the boiling points of the solvent and the feed for the effective separation, low latent heat of evaporation, high thermal and chemical stability, because stability that is also very important, because in some of the cases we are using the high temperature, low melting point, relatively inexpensive, non-toxic, non-corrosive, this is another requirement of the process, low viscosity, low interfacial tension. So, this was actually the part of the introduction to the chemical process industry, where we discuss about the status of the chemical process industry, raw material of the chemical process industry, and then the various unit processes and unit operation that is being used in chemical process industry. Now, in the next few modules we will be discussing one by one the different chemical process industry, and to start with the coal chemicals, we will start with the coal and coal chemicals, because now again earlier we started the chemical industry with from the coal to the same Fischer-Tropsch process, again people are going for the coal for the either it may be for the manufacture of synthesis gas, for the fertilizer manufacture, or from the synthesis gas to oil, or synthesis gas to various petrochemical. Now, we are talking about the coal to methanol technology, coal to plastic technology, and the China that has taken the major step in utilization of their coal resources for the manufacture of the synthesis gas through the road. But from very beginning earlier, because you see the coal, use of the coal and coal chemicals, first that actually we started using the coal chemicals from the coke oven plant. So, next in the next module, on the module 2 we will be discussing about the coal chemicals, coke oven plants, because the coke oven plant, that was the actually starting from where we are getting the aromatics and some of the even the ammonia, and many of the steel plants they are having the your fertilizer plant also ammonium sulphate or ammonium nitrate. And third module will be on the gasification of the coal, gasification of the petcoke, gasification of the biomass, that will be discussing that will be discussed in the lecture 3 of the module 2, where it will be detail about the gasification, what are the development that has taken place in the gasification, and why we are going for the petcoke or the biomass gasification.